Hello again and welcome back to Mr. Algebra. For this video we're going to discuss a little bit about the properties of real numbers. These first couple of properties are something that you're probably very familiar with. Equivalent expressions have the same value for all values of the variables. For example, as you can see right here, we have 3 plus 2, and that's equivalent to the expression of 5, or I could put anything in there that makes 5. I could put 4 plus 1, and that's still equivalent to 5. We could do it with variables or algebraic expressions as well. So we have 3n plus 2n, which would be equivalent to 5n, or we could write again, let's say 4n plus 1n. This next property, the commutative property, this one applies to addition and multiplication. And it simply says that changing the order of the add-ins or the factors does not change the product or the sum. The add-ins would be numbers that you would add together, so a and b are called add-ins. And if I switch them around and call it b plus a instead of a plus b, those are still equivalent to each other. So even if I wrote something like 4 plus 3, that's still equivalent to 3 plus 4. Now this rule right here of commutative property does not apply to subtraction, so don't make that mistake. Also true for multiplication, so a times b is still going to equal b times a. So let's use those same numbers again. Let's say I have 3 times 4, that's still going to equal 4 times 3. Now the b and the a here are what we refer to as factors, so anything you're going to multiply together is called a factor. Now these rules of commutative property do not apply to subtraction or division. They're only addition and multiplication properties. Next property we have here is the associative property. This one also applies to addition and multiplication only. So changing the grouping of the add-ins or factors does not change the sum or the product. So whether we add the first two here, a and b, or we come back here and we add the b, c first and then come back and add the a, we will end up with the same answer. So to keep this real simple, let's go with 1 plus 2 plus 3, and let's suppose that we want to add those together first versus 1 plus 2 plus 3, and we add the 2 and the 3 together. Now 1 plus 2 is going to give us 3 on this side plus 3 more, and that's going to give us 6 all the way down. And then on the next line we're going to have 1 plus, now 3 plus 2 is going to give us 5, and then we have 1 plus 5, which gives 6. You can see that the changing in the order does not change the sum. And the same thing would happen for multiplication using your factors. You can group them in any way you want, whichever way makes it easiest for you, but they do not apply to subtraction or division. Okay, so for our next property we have the additive identity. And that simply says that anytime you take a real number and add 0 to it, you get the original number back. So for example, a plus 0 equals a. So any number you put in there, let's say I have 7 plus 0, it's going to equal its own self. So additive identity. Then we have the additive inverse. And the additive inverse is any number and its opposite. And when you sum them up, you get 0. So if we have a plus negative a, we get 0. We sometimes use these when we're doing additive or addition property of equalities. So let me put a number in there. Let's say we have 5 plus negative 5. So going up 5 and then coming back 5, and you're still back at 0. There's another identity, and that one's related to the multiplicative identity, and that simply says that anytime you multiply a number by 1, it's equivalent to itself or its original number. And most of you are already familiar with this, so let's say I take the number 8 and I times by 1, that's still going to be 8. So identity means it gives itself. So we sometimes call that identity of multiplication, or in this case, multiplicative identity. Now we have another one called the multiplicative property of 0, or multiplication property of 0, and you'll see I have a little note here. You'll often hear me call this the zero product rule. That's one thing I used to call it. And it seems like kind of a duh moment, but it says that any number, any real number multiplied with 0 will always give you 0. And that seems a little odd to say, but let's say we have 3 times 0 equals 0, and that's going to happen every time. Now we'll come back and use this zero product rule later in the year when we start doing solving of quadratics. One of the techniques for solving is called factoring, and we set the two factors, which again, Factors are numbers to be multiplied, so two numbers that are multiplied equal 0. So in other words, if I had two separate numbers like a and b, and the product of that is equal to 0, then that means either a equals 0 or b equals 0 or both. And that's kind of what we do when we solve quadratics. We make them both equal 0. Our next one down is just to show you how to do with negative. So if you end up with a number that has a negative at the end, so this is called the multiplication property of -1. So let's say you're solving all your problems and you're trying to get the variable by itself and the variable ends up having a negative. Well, you can fix that by simply multiplying by -1. So multiplying by -1 will just give you the opposite. So if I have 5 and I times it by -1, that's simply going to give me a -5. Of course, if I had a -5 to begin with and I times it by -1, it's going to give me the opposite, which is +5. Multiplicative inverse, and this is really just reciprocals, but multiplicative inverse is just another name for multiplying by a reciprocal. That means you're flipping a number over or reversing the number for the ratio of two integers. So for example, let's say we have the number 3/4. The reciprocal or multiplicative inverse of that would be 4/3. And one of the nice things about this rule is you'll know you have multiplicative inverses or reciprocals because their product will always give you a +1. So if I multiply these two together and I go straight across, you'll see that 3 times 4 is going to give me 12. 4 times 3 is going to give me 12, and 12 over 12 is equal to +1. And that's what reciprocals are using the multiplicative inverse. Next we have the distributive property, and this kind of lets you get around the order of operations a little bit. It allows you to multiply numbers across add-ins, or sorry, across addition or subtraction. So if we look at what we have in the example here, we have b plus c inside the parentheses. And normally we'd have to do what's inside the parentheses before doing anything else. But since I don't know what b and c is, but I do have a multiplier on the outside, okay, which is a, I can still distribute the a by multiplying a and b and a and c together, and the result will be a times b plus a times c. Now this rule works across addition, as you just seen, and it also works when you multiply across subtraction. One thing it does not work is some people will try to take exponents on the outside and distribute across. You cannot do that. The distributive property is strictly for plain old multiplication, not repeated multiplication, which is exponents. And we'll see that in another video on powers. The transitive property is the next one we got here, and that's simply showing the equivalency of multiple items. So that's saying if I have A equal to B and B is equal to C, then it seems reasonable that A must also equal C, which means not only can you substitute, which we'll find out in a little bit, B and A and B and C, but you can also substitute A and C with each other since they are equivalency through the transitive property. Addition property of equality. A lot of us have seen this before. We use this when we're solving equations. So if we have A is equal to B, if I were to add C to both sides, and C is equivalent on both sides, so this C equals this C, then the result will still be this side equaling that side right there. So that's what the addition property of equality tells us. If they're equal to begin with, then adding equal amounts of both sides, they'll still be equal. Now there is a subtraction part to this. Now every subtraction can be rewritten as an addition problem. However, nowadays we do refer to this as the subtraction property of equality, but I'm not actually going to write that on there. But just be aware that if you see the word subtraction property of equality, that's what it's referring to. And then of course we got the other property of equality for multiplication. And multiplication property of equality is just like the addition. If I have two numbers that are already equal to each other If I then in turn multiply each side by the same amount, so multiplying both sides by c, they will still be equal to each other. So that's multiplication property equality. And there is one for division property equality. Like I said, we'll use these quite often when we are solving equations. So when we divide by something, we usually refer to it as the division property equality, even though it's technically multiplying with the reciprocal. Okay, so our last page here, the only thing that we use quite often would be the substitution property. These other three, not used quite as often, but you need to know what they are, especially when you get to geometry. Closure property. Let me just read what it says here, and I'll show you some examples. It said a set of numbers is said to be closed under a certain operation if when the operation is performed on two numbers from the set, we get another number from the same set as the answer. Now, the thing about the closure property is it's specific to what you're referring to. So if I want to know, are integers closed under addition? The answer to that is yes. Are integers closed under subtraction? The answer to that is yes. They're also closed under multiplication, but they are not closed under division. So what that means is if I have an integer, 3, and I add to it 7, and I get 10. So basically I have integer plus integer equals another integer. That's basically what we're saying. If you can always say that'll be true no matter what. So in this case, integer plus integer equals another integer of the same set. The answer to that is true. And that works for integer multiplication and subtraction as well. Integers are not closed under division, and a lot of our different number groups are not closed under division. I'll give you an example here. If I take 3 and I were to divide it by 4, I end up with 3/4. So what I get here is integer divided by integer. It equals not integer. So that's actually a real number right there. It's a ratio of two numbers, but it's not an integer. So you can see that integers are not closed under division. We'll talk about this a little bit more in class when we get some more examples to become more obvious. The reflexive property, that simply says that any value is equal to itself. There's not much to that one. Like I said, you'll use that probably more in geometry. Symmetric property. Some students cannot go left, cannot go right, let's say kind of like in sports. They don't like the variable to be on the right-hand side. They want it to be on the left-hand side at all times. So the symmetry property or the symmetric property allows me to do that. So if I have A equal to B, then I could just act like this is a pivot point here, spin that around and call that B equals A. So if I had a problem that looked like this, let's say it was 12 equals 2x plus 6, and you don't like the x being on this side, you can use the symmetry property to rewrite it as 2x plus 6 equals 12. Just spin it around basically, and that's an example of the symmetry property. Substitution is our last one here, and substitution should be pretty obvious, but it's a very powerful concept, a very powerful property that students overlook all year long. When in doubt, substitute. It says if A equals B, then A, this should be a little boldface, A may be replaced by B in any expression. Okay, so if we say A equals B, and we have over here, let's say B is equal to 7. If I have 2A plus 3, and I want to evaluate this, but I don't tell you what A equals other than it's equal to B, then you could take the equivalency of B, which is 7, and substitute it right there, because I could rewrite that as 2B plus 3, and we know that B is equal to 7. So when in doubt, try to substitute.